All right, so really quick, I was not able to come up with that solution on my own, but I went and read the Reddit page where people talked about it, and using their hints, I was able to figure out part two. It turns out that it's a trick that is specific to the exact inputs they used, which I don't like, but um, I should have paid attention to that. And so let me show you what that is really quickly. Um, so there's a couple things to notice. Um, One is that these offsets they gave, it turns out, are really close to the end. So like um, this input here, um, let's say I equals this, len I is 32 times, 10,000, we multiply it, so it's 320,000 long. So that, if I have something that's 320,000 characters long and the offset is 303,000, I'm looking very close to the end. Again, looking very close to the end, looking very close to the end. And now if I go to my input, um, it's 650,000. So if I do that, it's like 6.5 million. And if I look at the first 7 digits, it's 5.9 million. So that's already saying uh, I'm looking very close to the end again. The second thing to notice um, is that um, the way this pattern works is it starts with zeros and it multiplies by n for the nth position. So, um, you know, for the second position, I have zeros to my left. For the third position, I have zeros to my left. For the fourth position, I have zeros to my left, and so on. So basically, in order to figure out the value at any given position, I don't need to look things to my left. So uh, if I only care about the values starting towards the end of the string, that means that to figure that out, I only need things to its right, and I can throw out everything to its left. So I can already focus on the end of the string. So for these particular inputs, um, I can focus just on the end of the string and not worry about it. And then the final thing to notice is that this offset has basically um, n minus 1 zeros, where n is like the position, and then n minus one, n ones, right? So what that means is, let's say I'm in the second half of the string, so that the number of times I need to repeat these things is more than half the length of the string. That means that I get more than half the length of the string of zeros and the rest ones. And by the time the second zero comes in, I'm already off the end of the string. So um, basically, for the positions I care about, um, I have zeros up to that position, ones afterwards. So that basically, for each position, I'm just saying I want to sum up everything from here to the end, and then take the ones digit. So if you look at the examples that they give, um, this were like again. So if you look at the last position, I'm just summing up everything here to the end and taking the ones digit here. Again, this next last position, I'm summing up everything one to the end, and I'm taking the last digit. Here, I'm summing up everything one to the end, taking the last digit. Here, I'm summing up everything one to the end, taking the last digit. And now, once I cross that halfway mark, um, it changes. So, but in terms of dealing with things, in the second half of the string, that's all I need to do. And given the particular offsets they're giving us, uh, that's all we need to do. So that to solve the problem, we basically just have to say, let's say we want to do one phase. Again, we only care about things starting at our offset. For each of them, I just want to sum up to the end of the string and takes the ones digit. And now again, that's n squared, except that you can sum, if you sum backwards, you can just keep a running sum and go. So once you see that pattern, which again, I can't take credit for, I had to read the Reddit page to figure out that pattern. And most people didn't explain it very clearly, so I had to read like a bunch of them. But anyway, that works. So let me show you what I did, and it turns out to be like actually much simpler than the first parts. Um, so what I do is I just took the raw string because it's easier. The offset is the first 7 digits, and now I convert it to numbers and multiply it by 10,000. And again, this trick only works if the offset is in the second half of the string. So I'm just going to assert that that's the case. Um, and now for 100 times, we just want to do the following trick. And this is literally all that happens. So we start at the last position, which is length of numbers minus 1, total is 0, and I just do a while loop while the position is bigger than the offset, which is where I want to get to, and I don't care about things to its left. I add that value to the total. Then I take the ones digit, and now I can just replace that with the ones digit because I'm not going to need it anymore. I've already got it in my total, and I subtract 1. That's literally all that I need to do. So for instance, if you think about it on this one, I get 8, I replace it with the total. Here, I keep this running sum of 8. Then I go here, I add 7 to it, that's 15. Replace this with 5. Then I have 15, I go here, I add 6, that's 21. I replace it with 1. Then I go here, add 5 to my running total 21, that's 26. And I replace it with the ones digit. And that's as far as I can go because then I get this 8 times 6. Anyway, so that's what I'm doing. And that's all this does. And I just run that 100 times, and it's fast because it's basically, the offset is basically 50,000 numbers, right? So I'm just summing up 50,000 numbers, which is relatively fast, 100 times, and that's basically all I'm doing. And then I just return the numbers from the offset. So that works. Like I said, it requires. So on one hand, I'm disappointed that I didn't come up with that on my own. On the other hand, like it's always an irritation when you're solving a problem where your solution works for the specific inputs they gave you, but doesn't work for other inputs, and that's yeah. I gotta say I don't like that so much. But anyway, that's how it is, and did I cheat by looking at how other people solved it? Yeah, I did. So, but I'm okay with that. Um, and I still, once I figured out what was going on, I still wrote the code myself. So, it's semi cheating. Anyway, that's that. And hopefully I'll have better luck on day 17.